Hi, this is Craig Isaacson, and today I'm going to go over high-level Apex unit testing. Let's talk about what is Apex unit testing. So if you're familiar with the Force.com platform and you've written some Apex, you probably know by now that you need to have your classes essentially covered 75% in order to deploy those classes into production. So what does that mean? Basically, Salesforce put these unit tests in place, well, the requirement for the unit tests in place, basically to say that you need to have your code covered by these unit tests in order to get that into production. So what that means is we basically have to test all of our code that we write that needs to go into production. And by testing it, we basically write code that calls our code. The whole purpose of this is to make sure that all the code that you write is doing exactly what it's supposed to do. So a lot of people get hung up with the 75% coverage. Oh, I need that 75% coverage to get in production. I just need to have code that calls the code in order to make sure it gets in. When in actuality, you're actually supposed to be checking the functionality of the code with other code itself. And by doing this and checking the functionality, you can essentially gives you an extra step of QA when you're basically compiling and deploying code. So if you have unit tests that are failing, you know that there's something wrong, either with the code or there's a change that happened related to some code you've written that is basically going to make it so that these tests are going to fail. So when you write your tests, it's essentially performing functions of the code that you've written to make sure that what you've written is actually doing what it should. So you do basically, typically you'll do a test on a pass condition as well as a failure condition, and a lot of times you'll do some bulk testing as well if that's something that's going to be an issue with your code. And by doing this, you don't have to worry so much about the coverage amount, because if you're actually testing the functionality of your code, you're going to be getting into each one of those code blocks that you need to get into. So let's just hop in real quick, and what we're looking at here is just the developer console and Salesforce. What I have pulled up is just a standard unit test, common test setup class. So this is a class that Salesforce has provided as a standard test template, essentially, for unit testing in Salesforce. Now, this test in particular is a test that's used for essentially common test setup. So first, let's get into what makes up a unit test. So essentially, it's a class, and we have this @is_test annotation at the top of the class, and that tells the Salesforce environment that this is a test class. So this isn't something that we'll actually use in production. So this is what will, if you open up in the dev console, will pop up this run test button here. So now we'll get into the test methods. So inside of our test class, we also have test methods. These are essentially annotated as static test method, which tells the Salesforce environment that this is a test method. It returns void. It's not going to return any data. And we just name it whatever the name would be that matches what the functionality of the test is going to be. So since this is just a demo test method or test class with test methods, these are all generic names. So as you can see, we have multiple methods. So on top of the test method, we also have our test setup. So this annotation @test setup. This is something that's somewhat new. It basically makes it so you can set up all of the data for your tests, and this data that's set up in this method is going to be persistent through every test inside the class. So you can only have one @test setup method in each test class. So we have this one, and if it is annotated with @test setup, when the test is ran, this @test setup method will be ran first. So you don't have to worry about calling it with inside of any of your test methods at all. So that'll get ran, and it's going to basically set up the data for use for all the other tests. So something that's a little bit different from the Salesforce demo is the use of a static class, or basically a class where we can contain all of our data creation. So we have this idea of a test data creation class. And the test data creation class is really, as it says, it's a test class. We don't actually have any test methods in it, but what it does have is all of these static methods that are used to basically create all the data that we're going to use in our tests. So as you can see, our first method here, we have our create default accounts method. So what this is going to do is it's going to go ahead and create a list of accounts, a standard list of accounts that we need for our tests in our common test setup class. So as you can see, we have this, it's going to go ahead and create all of our accounts. It's going to check to see if our class level static variable should insert is true. If it is, it's going to go ahead and insert those, and then it's going to return those back in the method. So the great thing about using, say, a test data creation class to basically make all of these, make all of our data available, is that we can use it across multiple classes. So if you have ever written unit tests, you probably are familiar with creating data, because as you know, the data in the database is not available unless you specify is test see all data equals true. And that has its own headaches, and something that Salesforce and I myself would basically dissuade you from using that method. You don't want to have all of your data available because you're not actually testing your code the way it should be. You want to have a preset determined steps to get through your code to make sure it's working right. That way you're grabbing all of the right records, you have all the right data throughout all of the environments, and it should work no matter where that test gets ran. So after you, like I said, you get used to creating data for the test methods. And keeping those all in one spot allows you to, like I said, call those from multiple different classes. And that's super convenient because there's going to be so many objects that you're going to need inserted or created for pretty much all of your classes. So a good example is if you have a lot of custom settings that need to be set, you can basically call that in one spot, and all of your tests can use it. You don't have to be basically rewriting the wheel as it would. And the nice thing too is as you write unit tests and you start creating these creation methods for the tests themselves, you'll see that you'll end up starting to write less and less of those methods, as the test data creation class is going to contain pretty much what you're going to need to do your tests. So there's nothing worse than getting in there and you see that you have to create so many data. So if you think, thinking back to like if you have to create users and profiles and things like that, you could have to create upwards of 8 different objects just to set up the data the way it needs to be for your test. And that can be kind of cumbersome, trying to remember where all that is and how to do it, when you could essentially do it once in our test data creation and call that same method in your other classes. So if we hop back to our common test setup here, like I said, we have our test setup. It's going to create our data throughout the class. That's what we're going to use. Okay, now we're going to hop into our actual test methods. So when you're thinking about your test methods, you essentially know that your data is created up here in our setup method from our test setup. So we have data that we need to test. So typically you would have, let's say, a trigger or something that's running, or some sort of any code that you know is running that needs to do something. So you're basically going to invoke that code and then double check to make sure that what it's supposed to return is returning what it should. So that could either be, like I said, in a trigger, whether it be updating through that trigger, or if it's just static code within either some static methods, or if you have some controllers that need to be tested. It's all essentially the same thing. So there's going to be some sort of input, some sort of output. You're going to essentially pass the input in, make sure the output's right, and then you're going to do some asserts. So if we look at this test method 2, you can see that it's doing assert equals. And this system.assert equals, if these don't pass, that essentially means the test fails. So this is basically testing to make sure that the account was created successfully through that test setup method. And this is essentially the same thing. So it's looking for that same different account and just making sure that the account is not null. So it's pretty simple. We have an assert equals and assert not equals, and that's typically what you would do after you've ran the code for your that you're testing. So that kind of brings us down to the test.start test and test.stop test. These are two static methods that are used to basically denote that the test is actually going to start. So you can think of this test setup as well as all of this code here as basically setting up the test. And then the actual testing is going to happen after you start the test. So what that does is a couple of things. When you do the test.start test, it actually creates a whole set of new governor limits for the transaction. So if you think about it, when you run the setup and you're doing all of these, whether it be DML transactions or whether it be just queries, those are all going to add to your limits within that transaction. So in order to get past those limits, well, to make it more of a true test, because when you're actually testing it, it's not going to, let's say a user is going to open up a Visualforce page, and that Visualforce page has a controller. All of the information used to create all that data for that controller, you don't want all of those limits being passed into the limits for the actual test. So the test is only going to do the limits that are used for that test, and it's going to basically forget about everything before that. You can only do this once per test method, and yeah, so typically in here, this is where you would actually do your testing of your code, and then you would also have your asserts and assert equals and assert not equals in here as well. So you would test your code and then make sure that code is correct. Let's see, and then we have probably one other thing, without getting into some of the more complex things like testing callouts and things like that, and different standard controllers. Probably the most other used thing that we have is the system.runAs. So system.runAs is a pretty nice construct. Essentially, you can run it as a different user. So you can do this to test basically record visibility permissions against that user. This is just an example of running again as the user that's running the test itself. So what this does too, similar to test.start test, is it'll essentially run this in a whole new context. Another place where you actually need to use this is where if you're creating some users and creating some user shares or some group memberships, doing that without running as a system.runAs and running as a different user, you're going to run into some record locking errors that you're not going to be able to get past because you're trying to do too much in one transaction as far as the sharing is concerned. So that's when you would use the system.runAs. So system.runAs can only be ran in a test. It can only be ran once in the test. When you do that, all of the variables up here are still available here. And it's just going to run as that user that you pass in instead of the system user that's running the test itself. So another way to think about this is if you're actually creating a user and you're creating a profile and you want to test that profile, you can actually run as that user that you just created either here or in the test setup. And then that's going to make your test inside here run those checks as that user. When you are actually testing these, you can actually go ahead in the developer console and click Run Test. And this is actually going to run through the tests, and it's going to show up in this Test tab here. As you can see, it ran the tests and it was just fine. We had 2 pass, and then any of our classes that it was testing, they would be here, and you could actually open up those classes and see what lines are covered and what lines aren't. So let's just open up this random class. Based off of our previous test runs, we can see that we have it pretty much covered. Anything that's in red is not going to be covered, so those are a quick and easy way to see where your code's getting to in the test, and you can use that to basically figure out how you're going to update your test in the future to make it pass and to get to that 75% that you need for deployment. But like I said, I would recommend not even worrying about the 75%, more just worry about trying to test your code and making it right. And when you do that, the test is going to pass, and you're more than likely going to be way over 75% anyway. If you are testing all of it and there are some blocks that aren't getting into, that's probably where I would actually start looking at trying to get into those blocks that maybe might not get into very often, or it's very hard to get into the test. Those are all the different intricacies about running the test. So that's about it. So that's an overview of the tests using test data creation, running the test, different methods. We did the test.start test, system.run as, and actually running the test and checking our results. Thank you.